My name is Fozia Bukhari. I am a field student, Department of Zoology, Kohat University of Science and Technology under the supervision of Dr. Farmanullah Dawar. My research topic name is Isolation and Characterization of Gelatin from Scales of Labiroheta. The presentation outline of my research topic is Introduction, Gap Study, Objectives, Material and Methods, Results, Conclusions, Recommendations, and Differences. Gelatin is the abundant source of protein in the animal kingdom and are favorable for film formation, biodegradability, biocompatibility, and softness. Gelatin is commonly obtained through hydrolysis of collagen and has been widely used in food industries such as meat products, cakes, ice creams, beers, fruit juices as a gelling agent, stabilizer, emulsifier, thickener because of its unique functional properties. Based on the source from which it is derived, gelatin are classified as bovine gelatin, porcine gelatin, and fish gelatin. The most widely used form of gelatin are bovine and porcine gelatin because they are easily available and have low cost. Although skin and bones of mammals are traditional sources of gelatin production, they are unacceptable in some cases because of religious constraints and high risk of zoonotic diseases. Fish skins and scales have recently gained increased interest as an alternative sources to mammalian gelatin with no religious issues and have low zoonotic effect. Hence, there is immense interest that can be potentially used as an alternative to mammalian gelatin. There are two types of gelatin with distinct properties, including type A gelatin produced by acid hydrolysis and type B gelatin produced by base hydrolysis. Gap study. Fish byproduct, if they are not properly utilized and discarded as waste, can pollute the environment. Therefore, for extraction of gelatin from fish processing, byproduct can effectively overcome environmental pollution and will impart value to the otherwise waste product. Therefore, the present study is designed with an aim at the extraction and biochemical characterization of gelatin from scales of Labiroheta. Objectives: to synthesize and characterize gelatin from scales of Labiroheta, to compare physiochemical properties of the potential fish gelatin with commercially available gelatin. Methodology. First, I collected fishes from cohort, and then I removed scales from fishes with hands zipped in polyethylene bags and quickly transported to the laboratory. I took 500 grams of fish scales, washed and dried it, and then I prepared solution of sodium hydroxide and treated fish scales with 0.1 molar solution of sodium hydroxide to remove non-collagenous and unnecessary proteins from fish scales. I changed solution after every 3 hours. After treating fish scales with sodium hydroxide, I washed fish scales with distilled water until they were neutral or slightly acidic. After that, I prepared 0.4 molar solution of hydrochloric acid and treated fish scales with 0.4 molar solution of HCl for 90 minutes for demineralization. After that, the treated fish scales with HCl, I treated fish scales with HCl solution, washed it with distilled water so that it become weakly acidic. After that, distilled water was added to the fish scales and heated in autoclave at 121 degrees centigrade for 2 hours. Then I filtered resulting solution to the Wortsman filter paper so through this method, I isolated gelatin from fish scales. There are various methods to which characterization of gelatin take place. UV visible analysis shows detection of gelatin. SEM analysis shows morphology of gelatin. XRD analysis shows nature and crystalline size of gelatin. And FTIR analysis shows functional group identification. UV visible spectrophotometer was used to characterize in the range of wavelength 200 to 400. My peak also came between 200 to 400, which confirmed distinctive structure of gelatin. This is the UV visible analysis of commercial gelatin, isolated gelatin, and commercially available gelatin. FTIR spectra was recorded to detect the commercial and structural nature of gelatin powder. This is the FTIR of fish scale gelatin and commercially available gelatin. I have also compared physiochemical properties of potential fish gelatin and commercially available gelatin, and there is a little difference between potential fish gelatin and commercially available gelatin. Conclusion: This study reveals the potential of laboratory skill as raw material for gelatin production, giving relatively high yield. Gelatin was characterized using UV visible spectroscopy, FTIR, SEM, and XRD methods. Morphological investigation showed that this polymer exhibits microsporous morphology. FTIR spectrum indicates chemical bond formation of gelatin, where XRD analysis revealed the crystalline nature of it. And we also compared physiochemical properties of the laboratory fish scale gelatin and commercial available gelatin, and there is a little difference between their physiochemical properties. Acknowledgement. I am highly thankful to Dr. Famala Dawar, Assistant Professor, Department of Zoology, CUST, and I am also thankful to Dr. Saeed Ahmed Khan, Associate Professor, Department of Pharmacy, CUST. Thanks to all faculty members and lab fellows. References. Thank you.